Right, on a night where like the whole infrastructure here has gone offline first, we'll move on to the second talk, and Jake's going to talk about the future of web development and all things streams. We'll try and race through, try and finish if we can at past, not too much longer after that. Okay, I'll hand over again and off we go.
Cool, thank you. I love that. I wish that it didn't actually become a full clap and it was just like, all right, I'll carry on, shall I? Okay, right. So in the previous talk, I thought there was going to be more of a break between the two. I didn't realize you were going to have to listen to me for that long. Okay, so the emoji thing that we saw before, I think it's fair to say that it is like, it was fairly app-like in its feel. I know you can have discussions for ages on what is an app, what is a site, but I think so certainly design-wise and user experience-wise, Emoji was very much trying to be like a native app. I did build another app, which is Wiki Offline, because I wanted to show how Service Worker could be used to optimize something less app-like. So without Service Worker, this is all server rendered, like Wikipedia itself. My eventual aim was to make it work offline, but as a first pass, I just wanted to add Service Worker in as a performance enhancement. And as before, I built an app shell. And so for article pages, it would load this generic shell without the network. And then the page's JavaScript would handle fetching the appropriate article from the network. So without Service Worker, it was operating like any other website. But with Service Worker, I re-architected it to be a bit more like a single-page app. So I was dead excited when I sort of pulled this together. So you know where I went. Yes, I went straight to the comparinator. Fight! That's actually the last time you hear that sound. So first up, the online experience. So same rules as before. On the left, I have the plain old no Service Worker version, and on the right, the Service Worker version controlling things. And once again, they're loading through a throttled connection. So this is the online experience. And I watched this and I thought, shit, it's got slower. Like, I added a Service Worker and it's got slower, way slower. Here it is again. So the first render is actually quite quick, but the content, which some people would say is the important bit, is much, much slower. Like, a lot slower, 2 seconds slower on 3G. And I kind of had a bit of a panic about this because I thought, you know, we've really messed this Service Worker thing up. It was supposed to work for everything, but here it is failing for a sort of basic site. But it wasn't Service Worker that was the problem. I was using this app shell thing and letting JavaScript do the rest, which is fine if your design already dictates that you do this, but that wasn't the case here. I'd re-architected a site into a single-page app. And single-page apps are incredibly slow, and this is why I moan about frameworks all the time. Here's what it takes a website to get to first render. HTML starts downloading, CSS downloads, and then we render. And more HTML downloads, and it keeps rendering, and on it goes. I mean, we might download JavaScript as well, but that should be async or defer or something. Contrast this to a single-page app, where HTML downloads, usually instantly because it's very small, CSS downloads, and we get our first render, assuming the JavaScript isn't render blocking, which it often is, but we'll be kind and say it isn't. Anyway, this is just a basic UI render, no content. And then JavaScript downloads. It parses and executes. And then the JavaScript starts downloading the actual content. And once it has all of the content, it adds it to the page, and we get to render. And this is how slow happens. You know, like, in my case, I wasn't losing too much on the HTML download, CSS download, the JavaScript download, because they were all coming from the Service Worker. They were all cached. But the problem is at the bottom here. JavaScript has, when it's downloading content, it has to download all of it before it can show any of it. And the more I think about load time performance, the more I realize it isn't about the size of the CSS. It isn't about the size of the JavaScript. It all comes down to being progressive. And this is related to progressive enhancement, but it's not quite the same. I mean, like, show them what you've got. Like, because all the time you're loading, the user is watching and they are waiting for you. Don't make them wait until you've downloaded everything before showing them anything. Prioritize the first render, the first interaction. Show the user what you've got as you get it. And that's why I was failing. I was like hoarding content and only showing it once I downloaded it all. In retrospect, it's kind of obvious. Like, that would happen with a site, especially something with a lot of content. But for me, this was a hangover from app cache. So app cache very nearly lets you do the page shell thing, the app shell thing, but not quite. But it lets you get so close you can almost smell it. But just when you're almost done, it kind of just bats you away and goes, no, I'm going to fuck it up. I'm going to like destroy what you're trying to do here. So once app cache was out of the way, I was kind of like, really? It's gone? That means I can use all of the app shells I want and nothing's going to come in and stop me. But I didn't stop to think that the best answer wasn't the one that app cache nearly let me have. It was the thing that it didn't let me anywhere near. What I wanted was streaming. So this is a kind of simulation of streaming. The numbers are correct for like a piece of data of a certain size. And we can see here that things get to the final render happens somewhat quicker than without streaming. Or finish and then finish. And this is because the processing is happening at the same time as the fetching. So you save time there. But the important bit is we start to render like seconds before a non-streaming version. This is the full HTML spec loading here over a throttled connection. It's a 3 megabyte document. It is still downloading, but it gets on screen after only 20K is received. And that's the benefits of streaming. But for a long time, we had no access to this sort of stuff in JavaScript. But that is all changing. So we designed the Fetch API alongside Service Worker, mostly because we needed a low-level representation of requests and responses. But it was also a good opportunity to kind of create a much better API than XHR. So you fetch a URL, and you get a promise for a response. Now, this resolves once we have headers. We haven't received the whole response yet. We've just got the headers. And then you get to choose how to deal with the actual body of the response. So I could parse it as JSON, and that returns a promise as well. And eventually, I'll get the data out the other side. And this compresses down really nicely with arrow functions. And it's even nicer with async functions. The keyword, if you haven't seen this, the keyword await there pauses execution of the function until the promise resolves. But it's paused in an async way, so it doesn't block the thread. It's very similar to how a generator yields. I think it's on the Edge that has this in their experimental builds right now. We might have it in Canary by now, I'm not sure. But Babel lets you use it in other browsers. It'll either compile it down to generators, which are very similar. It's a really efficient way of doing it. Or it can compile it down to a kind of ugly switch statement. But so if you're targeting browsers that support generators, which you would if you're just writing a service worker, just use generators. Otherwise, you have to go all the way down to switch statements. But I think this produces much simpler, easier to read code. So I'm going to be using it in all of the examples in this talk. If you haven't encountered it before, you can just sort of pretend it's running synchronously, but it's not going to block the thread. It waits at every point you have a wait there. Anyway, you don't have to read the response as JSON. We added lots of different methods for reading it in different ways, like form, data, text, blob, array buffer. We added these methods for 2 reasons, because they're kind of nice convenience methods. And we wanted to ship this before streams were ready. And streams were always our kind of main goal. So we reserved response.body for the stream. And this has actually landed in Chrome and Opera around about a year ago. It's being actively developed in Firefox, Edge, and even Safari. This is something that they are in process of developing. And here's how you use it. Say I wanted to fetch the content of the HTML spec, but read it as a stream. First, we call response.body.getReader, and that gives us a lock to this reader, because only one thing can read a stream at a time. Then we can read some of the data, and reader.read gives us a promise, so we're going to await on that. Results is an object where .done is true if this stream has nothing to give us, nothing more, it's ended. Otherwise, result.value is a chunk of data, and in this case, it's going to be a uint8 array of bytes that have been received. It's not the whole response, it's just the first bit of it. And when we want the next part, we can call read again, and that'll give us the second bit, and so on. So if we wanted to get the length of the whole response, we could do something like this. We can create variables for our reads and for the total size, and then create a loop where we're just going to keep calling read while result.done is false. And in there, get the value, increase the total, and then log that out. And we can actually see that working if the live demo gods are going to let me. Ooh, don't like that spin. Oh, there we go. So we can see here in the log, it's just the same code you saw before, and you can see it's received a chunk of like 32K, but they're not all the same size. See, that one's 28K. You just have to sort of deal with that. It could be different sizes. Why is that not scrolling? There we go. Some of them are weirdly small chunks. It then depends on the browser and the server when these chunks come through. And you see it goes all the way down to like 8 megabytes. I'd said earlier that the HTML spec is 3 megabytes. It is, but when you're dealing with streams, it's already been unzipped. So it unzips to about 8 megabytes. So here we're inspecting parts of the response, but we don't have to keep it all in memory. We don't have to have that whole 8 megabytes in memory just to find out what the total size is. Now, a more practical use of this would be to search a stream for a given term or something. Say we wanted to search the HTML spec for the word horse. So we could do this. I mean, here we're reading the entire thing as text, and then seeing, does it include horse? But here we are having to read that whole 8 megabytes into memory and search the whole thing. So it's not very efficient. We can do better with streams. So instead of searching all the text and fetching all the text, we loop over the stream, just as we were doing before when we were looking at the size. But the problem here is result.value is this uint8 array of bytes, whereas we need a string for matching. Well, you can get away without a string, but let's get the actual string data here. And in future, doing this will be really easy. You can just pipe the body through a text decoder, and now this stream is going to yield text rather than bytes, a uint8 array of bytes. But this involves transform streams, and they haven't been fully spec'd yet, and they haven't been implemented yet. So you have to do it sort of a bit manually right now. So we fetch, get a reader, but also create a text decoder, and then loop over the stream as before, but we call decoder.decode and pass in result.value, and it will give us some text back. The stream true bit there is actually really important. So here's a demo. So in this example, I've got 3 uint8 arrays of 3 bytes each, and I'm going to create a decoder, and I'm going to loop over it. And for each of these uint8 arrays, I'm going to call decoder.decode, pass in that part. And if I run that, it's broken. And the reason for this is it treats each of them as separate things. And these 3 bytes, it's actually part of a character, not a whole character. So if I add in there, I can type from a distance. Does that look right? And if I run that, hey, it works. Excellent. So we get an empty string, the poop emoji, a toilet, an exclamation mark. And the reason for this is the emoji are 4 bytes long each. So now we've passed this stream true in. What happens is we pass the first array in, it gets those 3 characters, and it goes, this is not a whole thing. This is only part of a thing. So I'm going to keep that, and I'm going to return an empty string. Next time round, we pass in 3 more bytes. It takes the first byte and goes, I now have a character. Great, I'm going to store that. But now I have these 2 bytes, and that's part of a thing. So I'm going to send the poop emoji, because I know that's what I've got. That's a fully formed character. I'm going to keep those last 2 bytes back. And then the next call, we get the 2 bytes, and it adds those together and goes, yeah, this is a whole character. And then it gets onto the last byte, the 33, which is the code for an exclamation mark. And then it outputs both of those. So back to our code here. We can now check each chunk to see if it contains horse. And not only that, we can also cancel the download when we find a match. And this is where streams become really advantageous, because we found our result, great, we can stop downloading. We don't have to download that whole 8 megabytes. But this is a little bit buggy. It works fine if our chunks are something like my lovely, no match, horse running through the field. Yes, we have a match. Great. But what if the chunks are my lovely huh, and then horse running through the field? No match. We've missed a match because neither chunk contains horse. So when you're doing things like filtering streams or searching through them, you need to defend against this. You need to defend against the chunks being arbitrary sizes. So to do this, we need to keep a buffer. We need to keep a buffer that's the size of the thing we're searching for minus 1. So in our case, horse, 5 characters, we need a buffer of 4 characters. So this means we could see my lovely her, no match, but we retain the last 4 characters of the chunk and add it onto the next one, and we'll see horse appear there. Great, we found our match. So the code for that, same as before, we create a buffer to store those characters, loop through the stream, and we decode into the buffer, look for a match, and then if there's, we cancel if we find something. Otherwise, we reduce the buffer down to what we need, just that final 4 characters. So now we're searching a large document, we're keeping memory usage down, and we can stop the download early as well. So here's an actual a live demo of that. It's a little bit more code because I'm doing it case insensitive, and I'm kind of keeping a little bit more context to display at the end. And I kind of just picked the word horse sort of arbitrarily, but it did surprise me to find that there is a match, and it's because someone called Tommy Thorson has contributed to the spec, and it's like, great, thanks, Tommy. Anyone got any other suggestions of things to search for that might be in the spec, but probably not? Anything? This is a thing that happened. Like actually, the first time I gave this talk, it was in London as well. There was the same thing there. There was a bit of silence, and then someone at the back of the room just went, "Shit!" It's like, I hope that's not a heckle. I was like, okay, I'll give it a go. We'll see what happens. but shit has a match, which I was amazed at quite early on, and it's because there's a canvas shit region. Canvas hit. It's canvas shit region. What do you say, Brexit? There's not going to be a Brexit. There's not going to be a Brexit. Imagine if there is. No, boo, never mind. Okay, so I was talking to some developers in India, because I went to Bangalore earlier in the year. And connectivity is quite poor out there. But on this particular site, they were sending like a big set of JSON for search results, and they were saying, "Hey, we want to be able to better detect what kind of connection users on, because we want to send less results, fewer results, if they're on 2G versus 3G, because that will get them a faster render, because it's less to download." But detecting connectivity, like we saw before, is really unreliable. Like the system will think it's on 4G, but you'll be getting 2G speeds or Wi-Fi or whatever. So it's much better to serve something like this. Like, it's not JSON, but every line is JSON. And that's something we can stream. We can parse each line as it comes in, and we can sort of yield that object. So, and the benefit of this really depends on the type of connection you have and stuff. So let's just run it with the connection we've got here and see if it's different. So fetching the regular JSON, so it's taking 300 milliseconds. This might not be different, actually. This might not, because we've got a pretty fast connection. Yeah, it's not good. But if we were on something like 2G, cool. So fetching the JSON over 2G is going to take a lot longer. So around about 4 or 5 seconds. But in a streaming model, it takes about the same length of time to get the whole thing, but we get that first result in a fraction of the time, so we can deal with these results as they come in. I'm going to say it's not of benefit in every situation. If you've got a lightning fast connection, it doesn't matter, but if you've got a slower connection, the benefits really come through. I really like the URL that JSBin's given me here. Like, it looks like it's an insult towards a CDN, like more like Kakamai. So you might be wondering how I could use this to speed up the Wikipedia demo. Well, I can't, because although you can use fetch and get the responses in little chunks, JavaScript has no access to the streaming HTML parser, and that's what we need here. That's what the standard network connection is benefiting here. I mean, when I write something like this, it looks like I'm sort of appending HTML into the element, but plus equals is a getter and a setter. You're asking it for the inner HTML, at which point the browser has to serialize the whole DOM for that element, and then you add some more HTML on, and then you ask it to parse it. And doing this is a real performance nightmare. And like the elements at the start there get created potentially thousands of times, and performance is all over the place. I hope we can find an API. We can make an API to give access to the streaming HTML parser from the page. It's certainly something we want to do, but it's not there yet. But in Chrome Canary, you can create your own readable streams. It looks like that. Just new readable stream, and you pass in one or more of these methods. So say we wanted to create a readable stream of random numbers. So I've got an interval, and I'll show you why in a moment. Create a readable stream, and this start function. This is called like straight away as soon as you create the stream. And in here, I'm going to set up an interval, happens every second, and it pushes a random number onto the stream. And I'm also going to add this cancel method. And this is called if the thing reading the stream says, I've had enough, I'm not interested anymore. And we can use that to stop generating these random numbers. And that works today. Is it this one? Yeah, it is. So if the network works, so here we can see the numbers being generated. It generates free. And that's because here I'm getting the stream reader, calling read 3 times, and then I'm canceling, calling read again, so that 4th value never happens. Now, this is what we'd call a push stream, because these numbers are being generated all the time. And if something's not actually reading that data, those numbers are going to build up in memory, and eventually you can get a problem with that. So there is actually a better way to do this. You can create what's called a pull stream. So here I'm going to create a pull function. And this is called whenever the buffer is not full. So as things read from it, this pull function is going to happen more and more often. And here I'm just going to have a little promise that waits 1 second and then push the random number onto the stream. And this is much better because it's less code for one, but we're not generating random numbers if nothing's interested in receiving them. And we don't have to do cancellation for that reason, because it's just going to work, because it's not going to generate random numbers if nothing's asking. So your streams can yield anything. Like with fetch, we saw that it's a uint8 array of bytes. Here, it's random numbers. It can be objects as well. The designers of web streams, they spent a lot of time talking to the Node folks, because Node's had, what, 3 or 4 different versions of streams? Like, they've messed it up a few times, and they were really helpful in sort of saying, here's how we messed it up. Don't do these things. Don't make the same mistakes as us. And one of those things is having different stream types for different kinds of objects. And in this design, it's just one stream type, and it covers all the different objects. So you might be wondering how I can use this to speed up my Wikipedia demo. Well, I can't. Not just using streams on their own anyway, but things get a lot more interesting when they're combined with a service worker. So this already streams. Like, the browser's smart about it. It sees the request, the fetch, it's got a response that has a stream. It just connects the dots, it pipes it through. Getting from the cache, that streams as well. It'll stream from disk. It's great. But in Chrome Canary, you can create responses from your own streams. So in my fetch event here, I'm going to create an encoder. So this is opposite to what we saw before with text decoder. This is something that will be able to take a string and generate uint8 array of bytes out of it. And then I'm going to create a stream with a pull method, which waits a second and then pushes a paragraph containing a random number. And then you can see encoder.encode to create the bytes. So if you're creating a stream for a response, it has to be a uint8 array of bytes, and that will give us that. So now I'm going to create the response, passing in the stream as the first argument, and also some headers to say treat this as HTML. So let's run that. Yeah, here it is. So here it's fetching the page, and it's just getting these numbers in one by one. But you can see up at the top here, we're getting the browser spinner. As far as the page is concerned, it's just receiving a response really slowly. It's just like it was getting it from the network. And it's streaming that into the streaming HTML parser, and we're getting things appearing on the page gradually. You might be wondering how I can use this to speed up my Wikipedia demo. Well, I can. This will actually work, because before we were piping content straight into the browser streaming HTML parser, and that's the key to it all. This is the bit that app cache wouldn't let us anywhere near. Instead of turning a perfectly capable server-rendered site into a JavaScript-driven single-page app, I can actually use my service worker more like a server. So what I did for Wiki Offline, fetch the article header, body, and footer. So the header and the footer are coming from a cache, whereas the body is going to come from the network, falling back to the cache if it fails. And then I combine those streams together. Combine is a function I wrote. It's about 10 lines. It's not a lot, and it's something that's going to get easier as this Streams API matures. But it's combining those 3 streams into one single stream. So it reads the first stream into it, then the second, then the third, and then it's done. And now I create a new response from that using the stream. So I'm sending out a single response, but it's made of multiple parts from different places. Just like I do on the server. You get stuff from a database, you get some stuff from disk, you get some stuff from a web service, and you join them all together. Treating your service worker like a server really maps well to content things like blogs and Wikipedia, which are server-driven already. That's kind of how they work. And to see the result of this is the final time. We go to the comparinator. Fight! Here's how they compare. So on the left, it's the app shell render that we saw before, the service worker with the app shell. And on the right, the streaming service worker, both over 3G. Go. And the difference is kind of extraordinary. It's huge. But hey, we did see before that the app shell was a performance regression anyway. So let's compare it to the original. So on the left, straightforward server render, no service worker at all. And on the right, the streaming service worker render. So we get the benefit of that quick cached first render, which happens without the network. And that allows the network request for content to sort of get on screen quicker because there's less to request. I'll play it again. See, we get the top bar comes in straight away, and then the content comes in quite a lot ahead of it's almost a second faster for first render, and content is half a second faster, even though it's coming from the same network in each video. So needless to say, I'm really excited about streams. It doesn't mean that the app shell model is bad. We saw it with Emoji earlier, working really, really well. But a streaming solution will be faster and easier for you if you use server rendering already. Switching to an app shell model will be a lot of work and could land you with a performance regression. If you're already a single-page app, you have that performance regression already, so it doesn't matter. Consider streams if your initial content may come from the network. The benefit of streams is in being able to build content from multiple sources. If your initial content comes from the cache, there's less to benefit from streams, really. So with Emoji, the content was coming from the database, so not a lot of benefit to streams there. Consider streams if a partial content render is valuable to you, which it normally is, something where you can sort of render just when you've only got half of the content from the network or something like that. So Emoji didn't so much benefit from streams, but if you're looking to go offline first with like a news site, like Financial Times, or a shop like Amazon or your blog, streams could be a faster and easier way to do it. And they're landing in Chrome in sort of the next few weeks, and they're being actively developed in Firefox and Edge as well. If you want to know more about this stuff, then I wrote an article about it full of gushing praise, because I'm kind of obsessed with them right now. And it's got stupider demos in there as well, like sort of transcoding an MPEG into a GIF and stuff like that. And this one as well. This is here I'm fetching the Wikipedia article for cloud computing, but replacing on the fly the word cloud with but. And so it's able to sort of, while it's fetching the data from Wikipedia, it's able to get the transformed version on screen. Where's my favorite bit in this article? See if I can find it. There we go. Oracle, in June the 7th, 2012, Oracle announced the Oracle but. While aspects of the Oracle but are still in development, this but offering is poised. I love the phrase but offering. So what else? That's all the streaming stuff. What else are we working on right now? OK, progressive CSS. This is also something that's close to my heart. We've got a bit of a problem with CSS. Like, more often than not, we do this, right? We have one style sheet with everything in it. And while scripts are becoming async, we still often end up with this one big render blocking CSS resource, like containing all the styles for the whole site, and that just keeps getting bigger and bigger and bigger. And we did this because multiple resources were really bad in HTTP 1, but with HTTP 2, it's not such a problem. So instead, we can just include the CSS that this page needs. We can split it up. There's not really much of an overhead for doing that. But the problem here is that rendering anything on the page is blocked on all of these downloading, so including this amazing carousel thing, which might actually be at the bottom of the page. It's blocking the top of the page as well. So you could inline initial styles and then async load the rest. I know a few people who do that. But this will lead to a flash of unstyled content. So that's something you have to work around. So you could hide the unstyled content, and then when these bits of CSS load, they can show the elements that they're concerned with. And this actually works pretty well. It works well if you've got your inline styles and then one async style sheet. But when you have multiple, like here, well, these can load in any order. And this gives you a really janky loading experience. So this is basically the code you saw before. But the elements are coming in sort of whatever order they load. So you kind of see that heading's there. We get the footer, and then that disappears because it's got the comments. And then the comments disappear with the article. It's a really horrible experience. So what we're working on is allowing link elements to appear in the body of the page, so they can be placed just before the content that needs them. So now the browser can download all of the CSS in parallel, but it can block the rendering of just the stuff after the CSS until it loads. So you get this really nice sort of sequential loading of the page. So that means the stuff at the top of your page can render while the CSS for something at the bottom is still busy downloading. Nothing shifts around. So we really like this behavior. It's something that IE has done pretty much forever, but we like it, so we're going to steal it. That's how it works. It's something that's not spec'd, so we're kind of like, yeah, this is the best thing to do. We should take on that behavior. We should specify it as well. And it's something that Firefox are keen on as well. Or it could certainly be hacked in there, which is because I'm using Firefox for this demo. So what's next? Yeah, Houdini is another thing I'm excited about. This is giving you access to the way the browser lays out content, the way it paints, the way it composites. And all this is a bit of a black box right now, and this is going to give you access to that. Because we want it to be possible to polyfill like new layout systems without destroying performance, to create things like ripple effects without littering the DOM as well, and to be able to control compositing on a frame-by-frame basis. This is a demo my colleague Surma did, and you can see that the image sort of gets smaller and then locks to the top. It's not something you can do with CSS right now. Like, we've got things like position sticky, which can do bits of it, but the scaling isn't there. But this lets you just do it with JavaScript by running code on the compositor thread, so it's not blocking the scrolling there. I really like this. This is a big part of the extensible web stuff. So when we're seeing stuff like the thing WebKit added recently, the spring animation, that's going to animate stuff based on distance rather than just the time, I would much prefer to see something like this where you could run the code to do those animations on the compositor thread. And that means you're not restricted to like spring animations. You can do lots of different kinds of animations, but still get the benefit of it running off the main thread. This is a cross-browser effort. So I don't expect this to be in the browser this year, but 2017, we should see bits starting to land. Parts of it are in Canary already, like the paint worklet. The compositor worklet isn't, but hopefully that'll start landing in Canary this year. That's not all. We're kind of working on lots of other stuff to improve the platform as well. So things like the web Bluetooth, to let you connect to Bluetooth LE devices like fitness stuff and heart rate monitors and lights and stuff. We're going to have the media recorder and capture stream APIs, so you can create video from canvas elements. It'll give you access to the encoders to some degree. We're going to extend background sync to look into things like periodic syncing, background downloads as well, so you can download sort of large files and maybe even not have to have the browser running. And it's important for things like creating alarms or calendar reminders. So we want to be able to show notifications at a particular time. Even if the user has no connection. Frame timing API, this lets you kind of see the frame rate things are running at on users' machines. So we all, as developers, we tend to be working on very high-end machines, and it's like, wow, it's 60 frames a second, excellent. But this will give you some insight into, are your users seeing it at 10 frames a second? This is an exciting one. You're going to be able to vertically center things in CSS with one property. Like, holy shit. This is basically making align items and justify content, the Flexbox properties, just work on any elements, not just Flexbox, which is pretty good. Streams are coming as well. I'm really, really excited about those. You constrain layout. I don't know if anyone listens to the HTTP 203 podcast, but we've got a new one coming out tomorrow where we talk quite a lot about this. It's a way of improving layout performance by saying, like, anything inside this element is not going to affect anything outside it. And it's like an opt-in performance improvement. Grid layout is the layout system we have been waiting forever for, and it's finally coming to the browser, which I'm really excited about. Flexbox is pretty good, but Flexbox has sort of issues with sort of large page layouts, especially when it comes to a progressive render. This doesn't, so really looking forward to that. We're finally getting some of the good Sass stuff arriving in CSS, so custom properties, they're great. Foreign fetches coming to Service Worker. This is a way for when your page fetches something on another origin, like I said before, it will go to your service worker. But we're also going to allow it that if you don't handle it, that it will go on to the other origin service worker. So this will let things like Google Analytics provide an offline experience without you having to do anything, and font services as well will be able to handle their own caching. We're going to look at service worker events. Things like geocaching is something that's sort of on the table. These are all big privacy issues rather than API issues, so that's something we're looking at. This is huge as well, the intersection observer. So we'll tell you when an element sort of enters a viewport and leaves it, because we see lots of slowness, especially for ad tracking stuff, unfortunately, knowing when the ad is on the page, and it does that through scroll events, and that's causing loads of jank, so we're going to replace it with this. Streams are coming to the web. They're amazing. Really looking forward to them. We're going to allow you to create media sessions. This is something that native does really well, where when you're playing audio, you can tag it as a particular thing. And that will allow the system to create things like on the lock screen to play and pause it, and you'll be able to listen to that, or it'll appear on your watch and that. But it also means you get to interact with audio on running in other tabs. So if you say, hey, this sound that I'm playing is like music, and that means that you'll get the little bar on the lock screen. But it also means if another tab plays a notification sound, then the music will sort of lower in volume and then come back up afterwards. If you say, hey, the sound I'm playing is a podcast, and another tab does a notification sound, it'll pause the podcast, notification happens, and then resume. All this stuff that's been on native for a long time. JavaScript modules are in development now, revolutionize how we load JavaScript. Lots of the ES stuff, especially excited about the async function stuff like I was using in the talk earlier. Cancelable promises are being worked on as well, and that's really important for a lot of APIs are going to need that, especially fetch. Bitmap manipulation in a worker. If you're creating notifications in a worker, you'll be able to generate the icons dynamically. Maybe if it's a chat between two people, you'll be able to take those bitmaps and combine them in a worker. That's huge. This one is really important. A sensible payment system on the web. I'm a little bit bitter about this because I think Apple kind of screwed us over I'm really angry about it because they put out a blog post where they were saying, we're not going to do prefixes anymore. And then they went and put out a prefix. They sort of did the payment stuff. It's a real Brexity thing to do. So I'm a bit angry about that. But we are now sort of under pressure to also ship payments, which I suppose is a good thing in the long run. But we are insisting on doing the standardized version rather than sort of just coming out with Android Pay or something like that. So I'm really hoping that's going to start landing later this year. It means we're going to have to do it a bit quicker than we would have otherwise. So hopefully we won't end up in a position where we have to change the API that we ship. Persistent storage. This is important for if you, because the browser can just get rid of stuff that's stored whenever it wants. It does it a whole origin at a time if it's Cache API or IndexedDB. But we want to provide a way where you request permission to say, hey, I want to store stuff forever. And it'll be the user has to grant this or indicate it in some way. But it means that now the user is responsible for removing that. So if the device becomes under storage pressure, it's not going to be your stuff's not going to be removed automatically. But the user will be presented with the information and say, look, you've run out of space. But this origin is using 3 gigabytes. This one's using 500 megabytes. Which one do you like the least? Which one do you want to get rid of? Presentation API is all about casting to different screens. It's basically the kind of web standards way of doing Chromecast. There's WebNFC, WebUSB, WebBarbecue. I made that one up. That's not real. Streams, they're coming to the web. They're really exciting. Looking forward to those. The next iteration of WebGL. I don't understand WebGL. It's a mystery to me. Every time I try and learn it, I go to a page, WebGL tutorial, and I watch the scroll bar get smaller and smaller and smaller. And I drag down to the bottom, and it says, congratulations, you've drawn a triangle. Right. But it's great. I like the demos. The demos are cool. Web animations, that continues to ship. More features are landing there. And of course, we cannot forget about streams. So we're taking improving the web sort of pretty seriously right now. And all of these are open standards. And most of them are cross-browser efforts, working especially close with Microsoft and Firefox. This is the future. There's a lot of stuff to look forward to here. But the most important thing is what's possible today. What your current projects could be doing, what your next project could be doing. And the important things are like security, not only in terms of what your users send you, but also data that you send your users. An instant first experience, like for that very first visit, because this is where we beat the App Store by a country mile, because you can just go to a URL and it works straight away. We want a slick user experience, like 60 frames a second, reacting to users really, really quickly, the rail model, we call it. Avoid content shifting around on the screen. We want things to be network resilient, which is mostly what I've been talking about, and to be able to add it to the home screen, which is like a part in like an evolving part of the story of where web can become first class on the operating system. And we want to be able to sort of engage the user later on, like things like push messages, background sync. We just need to be careful not to fall into the realm of spam because the user will just disable that for your site really quickly. But the key point that encompasses it all for me is being progressive. Like during the London Olympic ceremony, right, which I guess we all watched, like Tim Berners-Lee tweeted, "This is for everyone," which I think was a really important message. Because a true progressive web app works on the devices your users have, like be it a low-end phone or a really powerful laptop, and adds in extra features using progressive enhancement. It will work on the browser the user has. It will work on the input and output devices the user has, be it like a 4K screen, a tiny phone screen, or a screen reader. It should work on those. And they work on the connection the user has from like San Francisco, where everyone has a fiber connection right into their eyeball, or to the London to Brighton line, where it's just Wi-Fi all of the way every day. This is how we compete with native. And on that note, I want to compare the launching of a native app, which is Google Photos in this case, quite a well-built app, to Emoji from the previous talk. I'm going to hit them at the same time. It's so close. It's so close. Emoji is 0.2 seconds slower to show content. It's 200 milliseconds. It's next to nothing. And that's compared to a really well-built native app. But that is also starting from cold. That is when the browser is not in memory at all. If the browser is in memory, things look different. So if the user has used the browser sometime recently, which, let's face it, the browser is a pretty popular app, so it's likely to be in memory, this happens. This is a progressive web app beating native to content render by almost half a second. And that's the power of like service worker and offline first. And that's why I'm excited about the future of the web. Thank you very much. Cheers. Hey.
Thank you very much for that, Jake. Superb talks tonight. So thank you from me and the rest of London Web Performance Committee. Right, no pizzas yet, right? So we have at least a little bit of time for questions. So we'll try and keep it short and sweet and to the point, and we'll go from there. Anyway, first up. No questions, right, there you go.
Yeah, it's not, if you don't ask questions, you don't get pizza sooner. That's not how it works. I think the pizza's still arriving.
Yeah, so in terms of like content management systems, are there like potential cases where you might have the ability for general users just to define what assets might be cached?
Yeah, and this is something we want web developers to be creating a library for this. It's something that we've got some stuff there already. We've got SW Precache and SW Toolbox, which are libraries that have been built by Googlers. But we definitely, like, if that doesn't meet your use case, we urge you to sort of create a system that can do that. So when it comes to caching content, like in the install event, in the examples I gave, I was listing out the URLs to cache. You could fetch some JSON to find out which URLs you should cache, and that would be something you could go to the content management system and find that, which, when the user's presented with it, could just be, type in the things you want cached, and it will figure it out dynamically.
Hi. I was just wondering if a streaming JSON parser was a thing, could ever be a thing. Does it make sense?
Yeah, and there is actually stuff already. You'll find it on GitHub. I'm unsure what the benefits of it are. Like, it's so. Sure. The problem with it is it becomes difficult to know when to yield. And so when you actually go for a full streaming JSON parser, you're having to you get every little bit of instruction, like here comes a string. You can't stream an individual string. That doesn't work. But yeah, you get information like here's the next array item, here's the next array item. That exists. My take on that was most of the time just doing the new line thing is because then you get to decide where the yield points are. It could be item by item, it could be something else. And the code for it is it's like 10 lines, whereas a streaming JSON parser is huge. But having said that, the browser does have a streaming JSON parser in there already. And certainly one of the rules of the extensible web is if the code is in there for the browser already, we should be exposing it to developers. Otherwise, it's sitting there being unused. Someone.
Hey, so I was wondering, looking at the progressive CSS, in comparison to using a web component where the CSS would be progressive anyway because it's part of the component, right? How you would comparison the two?
So web components will load. So you still need some CSS on the page to define the sort of layout between multiple components. If your sort of very outer element is a web component, then you're blocked on the JavaScript downloading for that. You can load web components async, but then you're still going to want some CSS to sort of define what area these elements should take up so they don't sort of shift around the page as they load. CSS within a web component, it's contained within the shadow DOM, but not within sort of the rest of the component. So you can still benefit from that sort of progressive loading of CSS within a web component as well.
Hi. In the example you showed with the caching, with service worker caching, you used you briefly touched onto the IndexedDB.
Yeah.
Would you say that it's okay to, if you're making a request and you're getting a JSON response back, to rather just store it using the service worker cache, or is it better to use IndexedDB together, or is there like a limit? Or
if you need to access a particular, just a part of that JSON, or if you need to like loop through parts of it or like index it, reorder it, then IndexedDB has those features. Just caching a request and response, the cache API makes that a lot simpler. It also supports streaming, whereas IndexedDB doesn't. If it's JSON, obviously it's maybe not such a big deal to have the streaming. But I've not seen a whole lot of people using IndexedDB willingly when there's an alternative. I've actually seen the opposite. I've seen people create key value stores using the cache API, which is kind of a little bit crazy, because we should just have async local storage for those cases. But yeah, you can use, the only thing you'll lose by using IndexedDB is the streaming, unless you're doing iteration yourself, in which case you're kind of inventing it from scratch.
Hello. It's kind of similar to the question over there. When you've got loads of resources which you might want to cache, but the life cycle of the resources isn't really related to the life cycle of the service worker.
Mm-hmm.
So we've got loads of microservices building their own things. How might you handle that scenario where you want to kind of hydrate the cache for everything constantly?
So the closest example that I showed was the avatars one, where you're caching the avatars as they're requested. I was doing that within the service worker, but the caches API is also available on the page. So you can do that from the page as well, and just like .add all or .put whenever you want to cache stuff. So trying to think of other cases where you would want to do that. Yeah, avatars is one. Actually, with Wiki Offline, when you cache, when you actually click, I want this article offline, I just run all that code on the page, because I may as well, because that's where I've got the click event. I've got the cache there, so I can add stuff to it. The way you get around it is, the way you version a cache to a particular version of the service worker is by giving it like a V1, V2, and then in your next version of the service worker, it's going to bump that number. If you're not wanting that, don't give it the version number, just call it avatars or articles or something like that.
Right.
I'm just wondering around service workers and security. So is there a potential for the service workers to be hijacked to basically interact and affect the output of your website?
So we made them, they have to be same origin, because that was one of the things if someone runs, if you've got an XSS flaw, we didn't want someone to be able to go and register a service worker of evil.com. So so the requirements are, if you were going to run this attack, you would need to have an XSS on the page, so you can call register. You would also need to have some way of creating a resource from scratch on that origin. It also needs to have a JavaScript content type. So yeah, it would need to look like JavaScript to the browser, and you need to put the script file in a high enough directory that you want to control. And this was something we weren't too happy about when we did it, but it does sort of make it easier, more difficult for that attack to happen. But the reason we did that is because we see a lot of sort of universities and sites like that where they have like tilde username, and they think that's a meaningful security boundary on the web, even though it's not. So we didn't want like tilde Jake to be able to override requests on tilde Alex. So yeah, if you wanted to control both, your service worker would have to be parent to those two. So yeah, I mean, there is an attack that's possible there. but there's a header sent out with every service worker request, so you'd be able to see from your logs, like, oh, I don't expect that there. And you could also, as a server, say, any requests with that header, just ignore them. You know, this sort of return a blank response. And if you do have that hack happens, then you can find out where the resource is, and instead, you know, return a service worker that just unregisters itself, and that's it done.
Okay, we'll make this the last question because the pizza's on its way up, and I need to create some space.
For the service worker cache, is there a maximum size, and does that differ per browser or device?
I mean, so it's not got its own limit. It's, well, in Chrome anyway, we have a limit for origin storage. So that's a combination of IndexedDB, local storage, old stuff like the file system API, WebSQL, and storage as the cache API. It's the amount of space you get differs per device. It's kind of based on a rough percentage of free space the device has, but obviously that can change later on, and the browser will sort of react to a storage issue and start deleting whole origins that have been, you know, not used recently. Once you have the persistent storage, you can store as much as you want. You can flood the hard drive with, you can just use all that's there. But when you do that, the browser will say, you know, you're out of space. Here's the person who's doing it. Do you want to stop them ever doing that again?
Okay, well, on that question, I'd just like to say thank you from everyone, Jake, again, for talking for an hour and a half. It's no mean feat. So thank you very much, and been delighted to have you come along.